Hi everybody. Today we're going to talk about periodic data, and we're going to use kind of a weird example. So you'll need to start on page 199 of your book. And this whole story deals with kind of one situation, and it's right up here in the beginning. So we've got Stacy has a new bike. All right, so this is where we're at. The bike has 24-inch diameter wheels and 6-inch diameter training wheels. The horizontal distance between the center of the 24-inch wheel and the center of one 6-inch training wheel is 36 inches. Stacy's riding at a steady pace, and the 24-inch wheel rotates every 4 seconds. As Stacy is riding down the street, her bike runs over a freshly painted parking stripe, and each wheel picks up a narrow strip of fresh paint that leaves a mark on the pavement. So now we can see, pavement, the wheel goes around, and we can see where the paint hits the pavement. So we can see not just the paint on the wheel, we can always also see the mark on the pavement. So we've got some things here that they're helping us sort of break this information down, because that was kind of a lot going on. The figure at the right is sort of the basics of the whole thing. So we're going to label all the segments based on what we were just found out. So the big wheel has a 24-inch diameter, and again, that's the diameter, not the radius. There is 36 inches between the big wheel and the small wheel, and the training wheel has a 6-inch diameter. Some additional information that was important, it says summarize any additional information. So we have one rotation every 4 seconds. And this is for the big wheel, for the larger wheel, the 24-inch diameter wheel. So if we think about what's happening here, it says on this little graph, let t equals 0, it's time when Stacy's front wheel first crosses the freshly painted stripe. Sketch the graph of the height above the pavement, the paint spot. So we know that if it's once every 4 seconds, so that'll be 8 seconds. So we also know the tallest part is 24 inches. Looks like we could go by 3s, sorry, I can't count. So this will be 6. Here's 12. That's important to know because that's halfway. And then this one is 18. We don't think we need to label them all. So we know at t equals 0, it's on the ground. Think about where else it'll be on the ground, right? It's going to be on the ground again at 4, 8. So this is what we mean by periodic data, meaning every so often the same thing occurs. So every 4 seconds, that paint is back on the ground. So in between there, it's going to be at its tallest. So at 2, it's at the tall, and at 6 seconds, it'd be at the absolute maximum height. And then obviously in between the low and the high, it has to go from low to high. So it's however you think it might look like. Here we go. We'll just connect those dots. And so that's what we mean by periodic. And we can predict this. Assuming she keeps the same pace, we can, how far will she be in 20 seconds, 40 seconds? Where will the paint spot be at 80 seconds? So this is what we mean by periodic. When you have a graph of like a polynomial, you have no prediction. You have no idea what's happening. But periodic graphs, they're super predictable, and they're usually very easy to work with because of that. So let's take a look at number 3 here. Now that we have that graph. Assume that Stacy's bike is on a path that runs perpendicular to the paint stripe. All right, so find the distance the front wheel travels in 4 seconds. Well, the front wheel will travel, it's their circumference, right? So if we think about taking the front wheel, right, the circumference of it, kind of cutting it, and then figuring out how long that would be in a straight line distance. So we know that the circumference is 2 pi r, or pi times diameter. So our circumference is 24 pi inches, and that's going to happen in 4 seconds. Because every 4 seconds, it's the all the way around. The circumference of the training wheel is So the radius on that is 3, or the diameter is 6. So however you want to look at it, it's going to be 6 pi. So we know that 24 pi takes 4 seconds. So training wheel will take how many seconds? That's seconds. So I did circumference over time. So if we cross multiply, I'll put this over here, we get 24 pi x equals 24 pi. And we divide by 24 pi because we're solving for x. We get x equals 1 second. So small wheel, 1 second. All right. So the little wheel doesn't start till 1.9 second. And then every 1 second, right? We know this. Every 1 second, it hits the ground. So just barely in front of each number. We know it's going to be back down low. And we also know that the max height is 6, right? We knew that from up here. So in between there somewhere, we know that it's going to be 6. So we kind of start to lose track a little bit. This wheel obviously is going it's going up and down. That paint is going up and down like crazy compared to the back wheel. So that kind of gives us a little visual as to what's happening. Sketch. So where do we think that might happen? Looks like it happens, gosh, I don't know, maybe, where do they, first time they intersect is right around here, but my graphs may be kind of bad. Somewhere between 3.5 and 4 seconds, I guess. Wheel, 4 seconds. That's going to probably be important to know here. So we go around. How many seconds will it take from t equals 0 to when the first runs over the freshly painted stripe? Ooh, that's kind of important to know. If you recall, the big wheel, golly, sorry about that. The big wheel to the little wheel, I know we just moved that. This was 36 inches. So we know that it's going to go 6 pi in 1 second. Right, if it goes 24 pi in 4 seconds, it goes 6 pi in 1 second. So we know 24 pi in 4 seconds. I keep coming back to this because I know that that's right. That's the big wheel. And we want to know, well, if we have 36 inches to cover, how many seconds is that? All right, that makes sense. So here's my big wheel that I know this is right, and I know this space is 36 inches. So let's figure out how much time this is. So again, I'm going to cross multiply. 24 pi x is equal to 144. And there's lots of other ways to figure this out. This was just what occurred to me to do. So when we simplify this, put this in the calculator, obviously because of that pi, we need a number. We get right about 1.90 seconds. So it's on a delay. That training wheel will take 1.9 seconds to hit the paint after the front wheel hits it. So now it wants to go back and graph the little wheel. All right, so I'm back on this other page. It says, using our sketch from 3C, estimate the time that the paint and the training wheel will be exactly the same height above the we have to use they want us to use that graph. All right, so kind of between 3.5, 3.5 to 4 seconds-ish, depending on your graph. A more accurate graph would obviously give us a better approximation. How many seconds after hitting the wet paint stripe will the paint first be at this position on the wheel? So again, we're looking at this. Here's our paint spot. And how much time? We're looking at time. Let's figure what fraction of the circle this is. This is 120 over 360, or 1/3 of the circle. Probably easier if we use 1/3. And we want to know, well, how much time out of 4 seconds? Because we know that it takes 4 seconds for that wheel to go. So we get 3x equals 4. So x equals 4/3, or about 1.3 repeating seconds, or 1 1/3 seconds. So I don't know if you can see where we're going with this, but we're heading towards special right triangles. This is a super weird way to do it, but that's what we're doing. It's a little bit more interesting than just going short leg over hypotenuse and all that other stuff. So explain how a special right triangle could be used to find the height of the paint spot. I'm going to draw a big circle here. All right, so we know that the radius is 12. I'm going to just sort of make like a square here. All right, so I know that all of these are 12s because I can put that radius anywhere I want to. Now there's my 120 degrees. This is 90, so I have 120 degrees, took away 90, that's 30 degrees. So there's this 30 degrees. This, I don't know. But I do know that this is a radius. Again, all these are 12, so all these radii, remember, can be put anywhere. Remember your rules. Hypotenuse is the short leg times 2. Long leg is the short leg times radical 3. So if we know the hypotenuse, remember, we're going to make something small. So I either multiply or divide. So if I know the hypotenuse, then I'm going to make something small, so I'm going to divide. Why would I multiply? It's going to get bigger. And I know the number, and I'm trying to make this relationship, the number between the hypotenuse and the short leg is 2. So I'm just going to take 12 and divide it by 2. So I know that this is 6. So the height of the paint spot is all of this, because this is where the paint is. And this is how we would measure it, straight up and down perpendicular to the ground. So I know I have 6 plus 12. So it looks like it would be about 18 inches. I know it says around in there is 1/10 of an inch, but we got an exact answer. So then let's think about this a little bit further. Is there any other instance during the first revolution where that would be at that paint spot would be at the same height? And if we think about 120 degrees here, right, so 30 degrees up, that's going to be 18 inches. It probably is going to be 18 inches over here too. So what other spot would that be? Well, this is 180 degrees. 30 degrees up from that. Right, that would be, right, because we know this has to be 30, so this would be 150 degrees. So what is the measure of that angle from here to here? I don't know if the 150 helps. I guess it would help because that is the answer, right? So it would be 140, so at 150 degrees. Oh wait, we have to go all the way from 0. Sorry, I'm going based on the unit circle. So if we come all the way from here, so that's going to be 90 plus 150, so that is 240 degrees because we start down here. So this page looks weird, but we are going to find the height of the paint spot at all of these times. Now we just did 1 1/3 seconds. We just did this one. So we know that 1 1/3 seconds is the same as 2 2/3 seconds, right? Because that's 2 2/3 would be here. So we just did these. We know these are 18 inches, so we don't have to do those. And in case you wonder about 30, 60, 90, 45, 45, 90 rules, there they are. That's the only place in the book you'll find them. So you can see if you like these rules better. Sometimes it helps if you just write the numbers. I'm going to draw this backwards on purpose. This is the 30. 30 is across from the short leg. And so across from the 30 is the x. 2x is the hypotenuse, and x radical 3 is the long leg. In a 45, 45, 90, the legs are the same, and the hypotenuse is x radical 2. Now we are going to focus on 30, 60, 90 rules, and in your assignment, you're going to focus on the 45, 45, 90 rules. So these pictures are going to be a little bit tiny, so I'm going to make this a little bit bigger. So if we think about 1/3 of a second, right, 1/3 of a second is going to be 30 degrees, right? So we know that that's 30 degrees. Every 1/3 of a second is 30 degrees. And so this will be 60 degrees and so on. 1 second, right? We know that 1 second because it's 4. It takes 4 to go around. So this is 1 second, 2 seconds, 3 seconds, 4 seconds. So I kind of worked backwards. I just took that, divided it by 3. Put it into thirds. So this will be right here. So 1 second is going to be perpendicular to the ground, which is the radius. So we know that 1 second is 12 inches. We know that 2 seconds, we might as well do these. 2 seconds would be straight up. Straight up, of course, is 24 inches. 3 seconds, because we just drew it, right? So we know 3 is here, but 3 would be all of this. So that's how long it takes, but the measurement is to the ground. Remember, we always go straight down when we draw stuff. This really ties in well with how we draw the triangles from yesterday. This would also be 12 inches, and then of course 4 seconds, it'll be right back on the ground again. So this is 0 inches. So we can get those straight line ones done. Oops, sorry, just drew all over that. So let's go back to the 30. And we're just trying to figure out how high off the ground this is. Oh my gosh, why is it not writing? Sorry. All we want to do is this right here. Tiny little spot. That's it. We know this is a radius, so this is 12. Remember, when you draw your right angle, this is not a radius right here because this doesn't technically hit the side of the circle. So you got to be careful where you put your radius. Make sure you put your radius from the center to the edge. So we know the hypotenuse is 12, which means the short leg, which is this one, opposite the 30 is 6, which means then the long leg is 6 radical 3. Well, we're looking for this space right here. So that's going to be, the radius kind of fits right in through here. I know you can tell the radius would be all of this, but we don't want all of that. We want to take the radius and we want to subtract the 6 radical 3. So this is going to be 12 minus 6 radical 3. 2/3 of a second. Again, be careful where you draw your radius. Oops, shaky. So this is 12, right? That's the radius is. And we know we're dealing with a 60-degree angle. So when you draw in your right triangle, now that changes things a little bit. That's still the hypotenuse, but now this is the short leg. So this is 6. And this is 6 radical 3. This is the paint spot, and we're trying to figure out, well, how high off the ground that is, and that's the same space as this over here. And so if we think about the radius being from center to the edge, and we want to take off that much from the triangle, so we're just doing 12 minus 6. So this one is 6 inches. Just did that one. We did 1 1/3 already. So 1 2/3. All right, so here's 1 second. That's your right angle. So 2/3 is 60 more degrees. So we'll just draw this in here like this. 60, here's my radius. All right, so I'm looking for the height of the paint spot, which this one's a little bit weird because it kind of comes through the circle, right? This is what we're looking for. We're looking for this height right here. And we know that this much is 12. So we just need that little space right here. So opposite the 30, this is your 60. So this is your long leg. This is the 6. This is the 6 radical 3. So in order to find the height of this paint spot, we want to add those together. So 12 plus 6 radical 3. These are all in inches. Sometimes I put it on there, sometimes I didn't. So we did the 2 seconds already. So 2 1/3. That's where we are. Anybody see a pattern yet? Remember, it's periodic. These are repeating. So far we haven't had any that repeat, but if we're at the top, so if we're at the top over here, and we're starting to come back down, the next one probably is this one. So this would be 12 plus 6 radical 3. Then you can see we have 18, then 12. You can see the pattern is for sure happening, right? So here's the maximum. I don't know why I can't get this right. So here's the maximum. And so now we're heading our way back down, 18, 12. And so this follows this direction. So we're going this direction. So after 12 comes the 6, because now we're here. It's the same thing as this guy. So this is 6 inches. And then the last one would be 12 minus 6 radical 3. And then, of course, the last one is 0. So that's why we like periodic data. You can get a lot done with not as many calculations. So your assignment is actually on the next page, page 202. And I know it's number 8, but it's however many questions. It's like 5 or 6 questions. And you're going to use the small circle. So remember, the small circle has different information. The small circle has a circumference, or a diameter rather, of 6. So you're going to use different numbers Also, it rotates a little bit different speed, so make sure you go back and pay attention to those numbers because they won't match these numbers. So please do that, and of course we'll go over all that next time I see you in class.